All right, so yeah, so I'm Max, founder of Skytree. Span out Skytree in 2014 from the European Space Agency, where I used to work as a system engineer. Actually, on that position, I was working on a life support system that scrubbed CO2 from the space capsules in order to basically stabilize CO2 levels. Otherwise, astronauts kind of suffocate. The CO2 that they exhale has nowhere to go, so something needs to be done about it in space. And so ESA developed a novel way and novel system to do that. And I worked on that life support system. My original co-founder and I had the idea of, hey, what if we could apply this to, the atmosphere? Because that's a good thing. CO2 removal and CO2 capture from the air is a tool in our toolbox to reverse climate change. It's not the answer, it's not the silver bullet, but it's certainly a tool. And we believe it's highly underdeveloped to date, and the development needs to be accelerated. So it's our mission as a company to scale carbon removal technology and commercialize it and get it out there so that we have this option and this other tool to fight climate change. Our first application is carbon filters in vehicles, buses, cars, EVs, any form of transportation, to be honest. We are right now at $1.2 million revenue level. So we've generated $1.2 million of revenue from paid proof of concepts in the automotive industry, and also a tier 1 manufacturing tie-up with a filter manufacturer in the automotive industry. We'll be integrating with our first client car this September, so that's great. And we have 5 patent families in place around our process. So what do we actually do and solve? So right now, especially in electric vehicles, you see a huge decrease in range in cold or hot weather. And this leads to range anxiety in drivers. The main reason for this range decrease is basically because the HVAC, the air conditioning, the heating and cooling system, needs to process all that cold or hot air and heat it or cool it, and all that power needs to come from the battery. And so the main reason between the range variability in EVs is because of the HVAC power consumption level. And the second issue that we address is air quality. Whereby right now roadside air can be 10 to 12 times worse than air elsewhere, even worse in certain cities such as New Delhi or Shanghai. Air filters in cars are notoriously unreliable. It totally depends on the car model that you have. And the pollution that is let into the cabin actually can build up as well. So it's just not a great air quality situation in car cabins right now. So what if we could create like a closed environment and like a closed air bubble as was created on the International Space Station, thereby drastically limiting the amount of fresh air load on the HVAC, reducing its power, and also limiting the amount of pollution that's brought into the space. Well, the reason we can't do that right now is you and I. As humans, we exhale about 1 kilo of CO2 every day and a lot of humidity. The CO2 builds up in the car cabin very quickly and leads to drowsiness of the driver. The water leads to condensation and reduced visibility through the windows. And that's where we come in. So Ursa carbon filters stabilize CO2 and humidity levels in indoor spaces, thereby enabling a clean air bubble to be created, fully recirculated air, which prevents the pollution, which reduces the amount of HVAC energy consumption, and therefore results in up to 20% range increases in EVs in cold weather, and an 80% reduction in the amount of pollution that comes into the space. The way we do this is a material that was developed by the European Space Agency and tested from 100 alternatives to be the highest performing at low concentration levels, and also low cost and durable. We've since optimized that material and we package it in a certain way to work best within applications such as automotive. The team itself consists of 15 FTEs. 4 PhDs. Our head of product is a former product lead out of the Bay Area, where he led product teams in the HVAC space, actually. Our head of technology, Alina, has a postdoc in materials. Floris, our CFO, has exited his own companies before, and I used to work at ESA, as you know, and study physics before that. We're also supported by a great bunch of advisors from across the automotive and carbon capture space. Excellent. And we've actually built the system. So we've tested it in a car. On the top right, you can see an image of the system that we built. We're building 4 more prototypes right now as we speak for our clients. And yes, as I said, we've tested it in our own test car in Amsterdam in our garage there. The way we actually make money is we tie up with like HVAC integrators such as a Bosch or Denso to design the system. We then license them the process, and then we sell them the filters. And then we have a second income stream from the after sales market and the filter resales directly to the OEMs or the drivers. So we have 2 ways of making money through the filter sales and licensing fees to our integration partners. The actual cost of the filters will be very low. I mean, the system for the space costs about $15 million. We actually capture more CO2 than the system in the space station right now, and we're able to sell our filters for less than $70. The addressable market is huge. I mean, in the EV space alone, there'll be 40 million vehicles by 2025 that could benefit from our system. That leads to a TAM of almost 2 billion and an offset potential of almost 170 million tons a year. We're due to make our first sales by the end of next year, pre-orders essentially. And after that, we are not going to stop there. We're going to do the same thing for buildings, where we're going to save carbon footprint on buildings, make them way more energy efficient, improve air quality in buildings, and then we're going to adapt our system to sell and siphon carbon from the air to be used in commodity production. So thank you very much.